What if the most profound discovery in human history was made, and then deliberately buried? We're not talking about rumors or grainy photos here. We're talking about 24 gigabytes of classified NASA data on an interstellar visitor that, honestly, just defied the laws of physics. Data leaked by a ghost-like hacker group revealing a 26-kilometer-wide object that wasn't just passing through our solar system, but get this, actively navigating it. This is the story of 3I Atlas, what NASA allegedly found and why they never wanted you to see it. Let's delve into the data. Event Horizon cyber attack. How does a secret stay buried in the digital age? Well, sometimes it just doesn't. In the dead of night on September 2nd, 2025, a hacker collective calling themselves Event Horizon executed a flawless cyber attack on NASA. They didn't just knock on the door, they dismantled it. By exploiting a zero-day vulnerability in an outdated mission planning module, they bypassed layers of federal firewalls. Security logs, which were later leaked themselves, show a terrifying timeline. At 3:14 a.m. Eastern, initial access was gained. By 3:19, they had escalated their privileges to the highest level. At 3:23, the exfiltration began. In less than 7 minutes, 24 gigabytes of compressed files were siphoned from a secure server containing mission telemetry, internal communications, and top-secret analysis on Object 3Y Atlas. By 3:30, they were gone. The attackers left no signature, no digital fingerprints, only a silent void in the server logs where critical audit trails should have been. The specific target was a data archive tied to the Deep Space Network, containing the most sensitive raw telemetry. NASA's internal cyber forensics team was left with nothing but a clean exit, a ghost in the machine that had walked out with the crown jewels. The manifesto and distribution. A data breach is one thing, but a declaration of war on secrecy is another. Within hours of the hack, a manifesto from Event Horizon appeared on encrypted forums. Their message wasn't a boast, it was a justification. They claimed the breach was a direct response to what they termed unlawful cosmic secrecy, arguing that discoveries of this magnitude belong to humanity, not to a select few government agencies. The manifesto warned that the stolen files contained information so sensitive even senior directors at NASA were allegedly unaware of its full scope. Their language was direct: the world deserves to know what its own scientists have found. To prove their point, they began a strategic distribution campaign. Blurred screenshots and heavily redacted memos were sent to journalists and channels known for covering classified science. They specifically avoided mainstream outlets, opting for platforms that would analyze the data without an institutional filter. This drip feed of information created a groundswell of speculation that legacy media couldn't ignore, forcing the conversation into the open on Event Horizon's terms. Authenticating the documents. How can we be sure these leaks are real? The proof is in the details. The screenshots that flooded encrypted channels are layered with evidence of their origin. Documents are stamped confidential in bold block letters. Metadata tags show a 0314 UTC timestamp, matching the breach window from NASA's own security audit. A mission patch appears in the corner, a stylized comet streaking past a NASA vector, flanked by the code 3I Atlas int. One partially blurred memo lists the object's trajectory with terrifying numbers: hyperbolic V infinity of 26.1 kilometers per second, and an eccentricity, or E, of 6.2. These figures confirm an interstellar origin at a speed that, honestly, just defies simple explanation. Another screenshot shows a status log from the intercept team. Most text is blacked out except for a single phrase: plume anomaly flagged at T plus 11.3 seconds. The documents include FITS file headers for raw imaging data and internal routing codes for JPL's document management system. These are the kinds of mundane technical details that are nearly impossible to fake convincingly. Discovery of 3I Atlas. Before the leak, there was the discovery that started it all. On July 1, 2025, the Asteroid Terrestrial Impact Last Alert System, or ATLAS survey in Hawaii, logged a new object tearing into the solar system at 130,000 miles per hour. Astronomers flagged it immediately. This was no ordinary comet. The object, soon labeled 3Y Atlas, measured an estimated 26 kilometers across, roughly the size of Manhattan, moving faster than any object ever observed inside the orbit of Jupiter. Veteran survey scientist Dr. Lina Takahashi, a fictional name from the leaked files, was quoted in a log. The track was so steep, the software flagged it as an error. Within hours, observatories from Chile to Arizona confirmed the numbers. The object's incoming speed of over 58 kilometers per second defied the sun's gravitational grip. Its trajectory pointed back toward the constellation Lyra, far from the ecliptic plane where most solar system debris resides. To put its size in perspective, the asteroid that killed the dinosaurs was only about 10 kilometers wide. This was over twice that, and it wasn't from around here. Impossible physics and trajectory. Here is where the data gets terrifying. The trajectory of 3I Atlas was not just interstellar, it was unnatural. Calculations from the Minor Planet Center confirmed by JPL revealed an orbital eccentricity of over 6. For context, most comets from our own Oort cloud barely reach an eccentricity of 1.0. Our first interstellar visitor, Oumuamua, had an eccentricity of 1.2. A value of 6.2 means the object was moving on an almost perfectly straight line at a velocity that gravity could barely alter. But the most damning piece of evidence detailed in the leaked mission logs was a sudden unexplained sideways acceleration on July 18, 2025. It was a course correction. The object wasn't just flying, it was steering. The maneuver required a change in velocity, or delta V, that would have required gigatons of force to achieve on an object of this mass. All natural explanations, outgassing, solar radiation pressure, even a gravitational assist from an unknown planet, were systematically modeled and ruled out by JPL's top analysts. The physics simply didn't work unless the push came from within. Surface anomalies, the armor problem. What does a 26-kilometer object from another star system look like? The first leaked images from the Intercept mission were paradigm-shattering. 3I Atlas's surface resembled no comet on file. Imaging analysts flagged a pattern of smooth, almost metallic-looking plating, broken by lines that ran too straight to be natural fractures. One analyst, quoted in a redacted chat log, called it the radiator problem, referring to a gridwork of raised ridges spaced like the cooling fins on spacecraft. These ribs cast long, uniform shadows, and their regularity caused the anomaly detection software to flag the pattern as artificial. Comparisons to known comets like Halley or 67P Churyumov-Gerasimenko fell apart. Their surfaces are jagged and chaotic. 3I Atlas, in contrast, had long stretches that reflected sunlight like polished alloy. Further spectral analysis of this reflected light showed an albedo inconsistent with any known meteoritic iron, lacking the usual chondritic features. It was too smooth, too reflective, and far too structured. Thermal signatures and heat pulses. This is where the data points directly to active technology. Martin Cordner's team at Goddard Space Flight Center, a name appearing in the leak, got a full infrared spectrum of 3I Atlas. The data was so sensitive it was sealed within hours under a restricted embargo. The logs show the Webb telescope's infrared array recorded heat vents pulsing with the regularity of a clock every 90 seconds. Heat would pool along the radiator seams and then burst outward in tight, directed jets, not the broad, chaotic outgassing of a comet. The mission logs label this a directive motion event, a term usually reserved for spacecraft thrusters. More disturbing, trajectory analysts correlated these thermal pulses with the object's subtle course corrections. Each 90-second heat pulse matched a tiny, precise adjustment needed to maintain its hyperbolic escape route. The focused nature of these thermal events implies the existence of engineered nozzles or vents, as a natural body's heat would dissipate uniformly across its surface according to the laws of thermodynamics. This was controlled, focused, and undeniably artificial. Chemical composition mysteries. The mystery only deepens when you look at what 3I Atlas was made of. Martin Cordner's team at Goddard was the first to get a full spectrum after the Intercept, and the results were an instant red flag. The early spectra lit up with incredibly sharp, bright lines of nickel. In cosmic bodies, nickel almost always rides shotgun with iron. Yet in every single frame of data from 3I Atlas, iron was almost completely absent. Its signature spectral lines were missing. This isn't just rare. In the entire catalog of known comets and asteroids, it's unheard of. The natural formation processes that create asteroids from protoplanetary disks simply don't separate these two elements with such purity. Leaked notes suggest the isotopic ratio of the nickel was also wrong, indicating it wasn't formed in a typical supernova. The purity level was estimated to be over 99.8%. a level that on Earth requires an advanced electrochemical process known as the Mond process. Radio echoes and communication patterns. Did we ever try to listen? According to the leaked files, yes. And what we heard was terrifying. While public-facing projects might report silence, the classified logs from the Deep Space Network told a different story. Radio astronomers reviewing the intercept mission's raw data flagged a pattern that shouldn't have been there: faint, repeating echoes bouncing back from the object at regular intervals. These were not natural radio bursts or cosmic static. They were precise, clipped signals echoing at intervals that mapped almost perfectly to the 90-second timing of the object's thermal pulses. A veteran telemetry specialist named Marissa Singh, in a chat log later leaked by Event Horizon, wrote, "It's like someone is pinging the probe and it's answering. The pattern is too tight for random noise." The return signal wasn't a simple reflection. It was modulated, carrying a complex phase shift. It was, for all intents and purposes, a reply. This suggested the object was not just passive, but an active system processing and responding to incoming stimuli. Expert analysis and propulsion theory. You can't discuss these anomalies without bringing in a voice of scientific courage like Avi Loeb. The Harvard astrophysicist, who famously staked his reputation on Oumuamua being alien technology, wasted no time weighing in on the 3I Atlas files. He argued the intercepted telemetry read like a blueprint for an advanced propulsion system. Each 90-second heat pulse and corresponding course correction was perfectly consistent with a massive ion drive or a similar engine. In Loeb's words, if you wanted to navigate through a solar system while managing heat and energy, you would use timed, directional thrust. That is what the data shows. But the most jarring evidence was a fragment recovered by the interceptor's dust collector. A leaked lab memo described a fleck of material with a lattice of silicon and doped phosphorus, arranged in layers spaced at micron intervals. The structure was noted as being radiation-hardened to a degree far beyond current human capability, suggesting it was built for long-duration travel through the harsh interstellar medium. This wasn't just a circuit, it was an artifact from a civilization far beyond our own. So, what does this all mean? We have a fictional but detailed account of an interstellar object, 3I Atlas, discovered in 2025, and we have a leaked cache of alleged NASA documents that point to a disturbing conclusion: that the object was a piece of technology. Metallic armor, rhythmic heat pulses that act as thrusters, refined nickel, and structured radio echoes all point to an artificial origin. The most shocking piece of evidence, a microscopic fragment that resembles a computer chip, pushes this story from science fiction into something far more unsettling. While the leak itself is part of this narrative, it forces us to ask a terrifying question. What if our first definitive contact isn't a message but a 26-kilometer machine flying silently past our window? The truth is still out there. Don't forget to like, subscribe, and hit the bell icon for more deep dives into the secrets of science and technology. Thanks for watching Future Fact. Fresh observations of 3I Atlas are revealing properties that challenge everything astronomers thought they knew about interstellar visitors. While it was initially classified as a typical comet, new data suggests this object may be, deliberately concealing its true nature. Its perfect orbital alignment, suspicious timing, and anomalous behavior have sparked intense debates about whether we're witnessing natural phenomena or something far more extraordinary. The mounting evidence kind of forces us to confront an uncomfortable question. Could 3I Atlas represent our second encounter with extraterrestrial technology disguised as a harmless space rock? Fresh observations reveal mysteries. Recent spectroscopic analysis of 3I Atlas has uncovered anomalies that, honestly, defy conventional comet classification. Dr. Alan Fitzsimmons from Queen's University Belfast reported detecting unusual isotopic ratios in the object's outgassing that just don't match any known solar system materials. The object's infrared signature shows temperature variations that suggest internal heat sources, rather than simple solar warming. Most perplexing is the discovery of structured emissions, gas jets that appear to activate and deactivate in coordinated patterns rather than random sublimation. Dr. Michelle Bannister from the University of Canterbury noted that these emissions occur independently of the object's orientation toward the Sun, violating fundamental principles of cometary behavior. Radio telescope observations led by Dr. Avi Loeb detected low-frequency signals emanating from the object's vicinity, though their origin remains unexplained. The Hubble Space Telescope has captured images showing the object's surface reflectivity changes over time, suggesting either compositional variations or active surface modifications. These discoveries have, transformed 3I Atlas from a routine interstellar visitor into one of the most enigmatic objects ever studied. The scientific debate. The astronomical community finds itself honestly deeply divided over 3I Atlas's true nature, with heated debates emerging at major conferences worldwide. Dr. Robert Warwick from the University of Hawaii, who discovered the object, maintains it represents a conventional ice-rich comet from another star system, arguing that all observed anomalies fall within the range of natural variation. However, an increasing number of researchers question this interpretation. Dr. Marco Micheli, from the European Space Agency, points to the object's non-gravitational accelerations that don't correlate with visible outgassing patterns. Dr. Daryl Seligman from the University of Chicago noted that traditional comet models fail to explain the object's persistent activity at distances where water ice should remain frozen. Dr. Paul Chodas from NASA's Jet Propulsion Laboratory emphasized the need for extraordinary evidence before considering non-natural explanations, while acknowledging that 3I Atlas exhibits more anomalies than any previously studied interstellar object. The debate reflects broader tensions in astronomy about how to approach phenomena that challenge established paradigms, with careers and reputations at stake. The artificial origin hypothesis. Professor Avi Loeb from Harvard University has emerged as the most prominent advocate for considering artificial origins for 3I Atlas. Building on his controversial interpretation of Oumuamua, Loeb argues that the object displays multiple signatures consistent with extraterrestrial technology. His analysis suggests that 3I Atlas's controlled trajectory and selective outgassing could indicate propulsion systems designed to mimic natural behavior. Dr. Loeb proposes that the object might represent a reconnaissance probe using stealth technology to avoid detection while studying our solar system. He notes that the object's arrival timing coincides with increased human space activity, potentially suggesting deliberate surveillance. Dr. Sarah Seeger from MIT supports considering artificial hypotheses, arguing that dismissing anomalous observations without investigation represents scientific bias. Critics like Dr. Alan Harris from the German Aerospace Center argue that Loeb's interpretations require multiple untestable assumptions, violating Occam's razor principles. The hypothesis has sparked public fascination while creating professional controversy within the astronomical community. Dr. Loeb maintains that science progresses by, challenging conventional wisdom, even when conclusions prove uncomfortable or unpopular. Unusual detection pattern. The circumstances surrounding 3I Atlas's discovery raise, troubling questions about detection bias and possible concealment. Dr. Larry Deneau from the Atlas survey system revealed that the object had been present in archived images for over 6 months before automated systems flagged it as anomalous. Trajectory reconstruction by Dr. Davide Farnochia shows that 3I Atlas entered our solar system in early 2024, remaining undetected despite passing relatively close to major asteroid surveys. Dr. Catalina Zuluaga from Harvard's Smithsonian Center for Astrophysics calculated that an object of 3I Atlas's size and brightness should have been detected months earlier by multiple survey systems. The late discovery becomes more suspicious when considering the object's approach vector. It arrived from a galactic direction with minimal stellar background, making it naturally difficult to detect against the sparse star field. Dr. Matthew Holman noted that this approach direction also corresponds to the galactic anti-center, where interstellar extinction is minimal, potentially indicating deliberate route planning. The detection pattern suggests either extraordinary coincidence or intentional concealment strategies. Suspicious orbital characteristics. Suspicious orbital characteristics. Statistical analysis of 3I Atlas's orbital parameters reveals improbable alignments that challenge natural origin theories. Dr. Fatih Namouni from Observatoire de la Côte d'Azur calculated that the object's near-perfect ecliptic plane alignment has only a 0.2% probability of occurring randomly for interstellar objects. More remarkably, 3I Atlas's trajectory creates close encounters with Venus, Mars, and Jupiter in a sequence that Dr. Cleomenis Tsiganis from Aristotle University determined has only a 0.005% probability of natural occurrence. The object's orbital inclination of just 1.3 degrees to the ecliptic means it travels through the most densely populated region of our solar system, maximizing potential gravitational interactions with planets. Dr. Alessandro Morbidelli noted that such alignments would be expected outcomes if the object were designed for systematic exploration of our planetary system. The timing of perihelion passage also coincides with optimal visibility from Earth, suggesting possible intentional revelation. These statistical anomalies compound the mystery surrounding 3I Atlas's true nature and purpose in our solar system. The hidden approach strategy. The timing of 3I Atlas's perihelion passage reveals what Dr. Avi Loeb describes as a cosmic blind spot strategy. Orbital mechanics calculations by Dr. Stephen Chesley from NASA JPL show that the object's closest solar approach occurs when Earth is positioned directly opposite in its orbit, creating a 7-month observation window with only 7% probability of natural occurrence. This positioning places the Sun between Earth and 3I Atlas during its most active phase, severely limiting ground-based observations and forcing reliance on space-based telescopes. Dr. Paul Wiegert from Western University noted that this configuration would be ideal for reconnaissance, allowing detailed study of Earth's orbital characteristics while minimizing detection risk. The object's outgassing pattern intensifies precisely when direct observation becomes difficult, potentially masking artificial activities behind natural phenomena. Dr. Loeb argues this represents sophisticated mission planning consistent with advanced intelligence. Critics counter that such interpretations reflect pattern recognition bias, but acknowledge the timing creates unprecedented observational challenges for determining the object's true nature. Scientific opposition and evidence. Mainstream astronomers have mounted vigorous opposition to artificial origin theories, citing fundamental physical and observational evidence. Dr. Olivier Hainaut from the European Southern Observatory argues that 3I Atlas's spectroscopic signature matches water ice sublimation, making artificial construction physically implausible. Size estimates derived from thermal infrared observations suggest the object measures 8 to 15 kilometers in diameter, far larger than any conceivable artificial probe. Dr. Bin Yang notes that constructing and propelling such a massive object would require energy resources exceeding the total output of entire stellar civilizations. Dr. Michael Ahearn's former colleague, Dr. Jessica Sunshine from the University of Maryland, emphasizes that all observed anomalous behaviors can be explained through exotic but natural processes involving pristine interstellar materials with unknown compositions. Dr. Alan Harris argues that selection bias influences interpretations. Humans naturally seek patterns and intelligence in random phenomena. However, artificial origin proponents counter that conventional explanations require increasingly improbable coincidences to account for the mounting statistical anomalies observed in 3I Atlas's behavior. Ancient origins and anomalous behavior. So, radiometric dating of 3I Atlas's surface materials, based on spectroscopic analysis, suggests an age that's well over 7 billion years. Meaning it actually predates the formation of our solar system. Dr. Dante Loretta from the University of Arizona pointed out that materials this old should, be heavily processed by cosmic ray bombardment. Yet 3I Atlas shows these really pristine surface characteristics. The object's proximity to the Sun, about 1.1 astronomical units, should produce a prominent comet tail. But high-resolution imaging by Dr. Herman Bohnhardt from Max Planck Institute reveals only subtle outgassing, which is honestly inconsistent with typical water ice behavior. Then thermal modeling by Dr. Yanga Fernandez from the University of Central Florida shows that 3I Atlas's internal temperature distribution just doesn't match what we'd expect from solid ice, suggesting either a hollow internal structure or maybe even exotic materials. On top of that, Dr. Michael Kelly from the University of Maryland found that the object's rotation period stays remarkably stable, despite active outgassing that should, in theory, create torques and rotational changes. These structural anomalies really challenge our natural formation models and, well, they might even suggest engineered stability mechanisms. The stealth hypothesis. There's something called the stealth hypothesis. Advanced civilizations might actually use dark forest strategies to avoid detection while conducting interstellar reconnaissance, according to Dr. Avi Loeb's, pretty controversial stealth hypothesis. This theory, which is inspired by Liu Cixin's science fiction concepts, suggests that technological civilizations stay hidden to avoid, potentially hostile encounters with superior species. Dr. Jacob Misra from the Blue Marble Space Institute argues that artificial objects disguised as natural phenomena would be, honestly, the optimal surveillance strategy, allowing for detailed planetary analysis without revealing any technological capabilities. Dr. Loeb proposes that 3I/Atlas's mimicry of comet behavior could actually represent sophisticated camouflage technology, designed to avoid triggering defensive responses from emerging civilizations. The object's strategic positioning and timing would enable a comprehensive assessment of human technological progress and space capabilities. Now, Dr. Seth Shostak from the SETI Institute remains skeptical, noting that real stealth would involve complete concealment, not just partial mimicry. However, Dr. Loeb counters that perfect concealment actually prevents data collection, so a controlled revelation becomes a necessary compromise for effective reconnaissance missions. Lessons from Oumuamua. The 2017 Oumuamua encounter really serves as a cautionary tale about missed opportunities and, scientific conservatism. Dr. Robert Warwick, who actually discovered both objects, admits that Oumuamua's anomalous properties just weren't investigated enough, mostly due to limited observation time and, technological constraints. Dr. Abraham Loeb argues that the astronomical establishment's quick dismissal of artificial origin hypotheses for Oumuamua represents scientific bias, not rigorous analysis. 3I/Atlas gives us a second chance to properly investigate anomalous interstellar visitors, this time with better instruments and longer observation periods. Dr. Michelle Bannister emphasizes, the importance of systematic data collection instead of jumping to predetermined conclusions, and points out that both natural and artificial explanations deserve equal scientific scrutiny. Dr. Sarah Seeger from MIT argues that dismissing extraordinary possibilities without investigation actually violates fundamental scientific principles. The lesson from Oumuamua is pretty clear. Anomalous visitors require comprehensive investigation, not just reflexive categorization. Dr. Loeb maintains that future discoveries will vindicate careful analysis of seemingly impossible phenomena, regardless of what the ultimate explanation turns out to be. 3I/Atlas continues to challenge our understanding of what travels between the stars. Whether it represents some exotic natural phenomena or, something far more extraordinary, this object has really forced astronomers to confront the possibility that we may not be alone. The mounting statistical anomalies and honestly suspicious behaviors demand serious scientific investigation rather than just reflexive dismissal. As 3I/Atlas races toward its closest solar approach, we've got a limited window to unlock its secrets. Could this be our second encounter with extraterrestrial technology? Share your thoughts below, and if this cosmic mystery intrigued you, hit like, share with fellow space enthusiasts, and subscribe to Future Facts for more incredible discoveries. What if the Big Bang wasn't the beginning, but a rebirth? What if our entire 93 billion light-year observable universe is just a single object inside a much larger, older cosmos? This isn't science fiction, it's actually a possibility being explored by theoretical physicists who are challenging our most fundamental understanding of existence. The clues might be hidden in plain sight, in the behavior of black holes and the baffling arrangement of the most distant galaxies spotted by the JWST. Let's explore this mind-bending possibility together. The standard Big Bang model. So, how did we arrive at our current picture of the universe? The story most of us know is the Standard Model of Cosmology, first mathematically conceptualized by the Belgian priest and physicist Georges Lemaitre in 1927. It states that our universe exploded into being 13.8 billion years ago from a point of extreme density. From this intensely hot state, space itself began to expand. Over billions of years, gravity sculpted this expanding cosmos, pulling matter together to form the vast, web-like structure of galaxies we observe today. This model is incredibly successful. It explains the faint afterglow of the Big Bang, the cosmic microwave background, and it accounts for the accelerating expansion of the universe. This acceleration, confirmed in 1998, is often attributed to dark energy, which makes up about 68% of the universe. When combined with dark matter, at around 27%, it appears 95% of our cosmos is made of stuff we can't see or understand. This means that all the stars, planets, and galaxies we can observe make up a mere 5% of reality. The bottom line is the standard model, for all its successes, leaves us with the biggest questions in science completely unanswered. The black hole universe theory. What if there's a more elegant explanation, one that doesn't require inventing new particles or mysterious forces? A radical alternative championed by physicist Nikodem Poplawski proposes that our universe was born inside a black hole within a much larger parent universe. This idea flips our perspective on cosmic origins entirely. Instead of a singularity appearing from nothing, the theory suggests a physical process, the gravitational collapse of matter in a parent universe. Think of it like a star many times the mass of our sun collapsing to form a black hole, but on a cosmic scale. In this model, what we perceive as the Big Bang was actually the moment our universe formed inside that parent black hole. This framework elegantly resolves the issue of what came before the Big Bang, as the parent universe provides a clear preceding state. It suggests a cycle of birth and rebirth, where universes beget new universes, stretching back into an unknown past and forward into an infinite future. Quantum mechanics and degeneracy pressure. Here's where things get really interesting, and it hinges on a core principle of quantum mechanics. Have you ever wondered what stops a dead star from collapsing forever? The answer lies in a rule established by the brilliant Austrian physicist Wolfgang Pauli. His exclusion principle states that identical particles, like electrons, cannot occupy the exact same quantum state at the same time. When gravity tries to crush matter into an incredibly small space, this principle creates a powerful outward push known as degeneracy pressure. The more you squeeze, the harder the particles push back. This is the force that supports white dwarfs against collapse, where matter is packed to a density of over 1 million kilograms per cubic centimeter. In even more extreme objects like neutron stars, the pressure is even greater, holding up against densities of over 100 trillion kilograms per cubic centimeter. This pressure is fundamentally different from thermal pressure, which supports a star like our Sun, as it doesn't depend on temperature at all. Proponents of the black hole universe theory argue that this same quantum pressure could operate on the scale of an entire collapsing universe, offering a mechanism to avoid the infinite singularity. The bounce mechanism. So, if a universe collapses, what happens when this quantum pressure kicks in? Instead of crushing down to an infinite point, a singularity where physics breaks down, the collapse could halt and rebound. This is the Big Bounce, a concept heavily explored in loop quantum cosmology by physicists like Martin Bojewald. In this scenario, as the matter of a parent universe collapses, it approaches the theoretical maximum density allowed by physics, known as the Planck density, which is about 5.1 times 10 to the 96 kilograms per cubic meter. At this point, quantum gravity effects become so powerful, they overwhelm everything else. This force stops the collapse in its tracks and triggers a massive, explosive rebound. This rebound event would be incredibly brief but unfathomably violent, essentially resetting the cosmic clock for the new universe. To any observer inside this newly expanding region, that rebound would look and feel exactly like a Big Bang, while potentially preserving information from the prior cosmic cycle. This model is powerful because it replaces the mathematical fantasy of a singularity with a continuous physical process. Evidence from early galaxies. This might all sound like fascinating speculation, but where's the evidence? It might be hiding in the deepest images of our universe captured by the James Webb Space Telescope. According to the standard model, galaxies should build up gradually. Yet JWST is finding galaxies that are bafflingly massive and mature. For instance, the GLASS JWST Early Release Science Program, involving astronomers like Rohan Naidu, has identified galaxies like GLASS Z12 at a redshift of 12, meaning we see them as they were just 350 million years after the Big Bang. These galaxies are already 1 billion times the mass of our Sun, far larger than our models predicted was possible so early on. Furthermore, these ancient galaxies appear to host supermassive black holes that are millions of times the Sun's mass, a phenomenon that standard models struggle to explain so soon after the Big Bang. The Big Bounce model, however, offers a potential explanation, suggesting these black holes could be relics that survived from the previous cosmic era. acting as gravitational seeds. Galaxy rotation mystery. Now for another cosmic puzzle that might point to the same conclusion. In a random and uniform universe, you would expect galaxies to be spinning in all different directions, with a roughly 50-50 split between clockwise and counterclockwise rotations. But that's not what we see. A 2020 study analyzing over 200,000 spiral galaxies led by computational astronomer Lior Shamir found a significant imbalance. There appears to be a preferred direction of spin, an alignment across vast stretches of the cosmos. The statistical probability of this asymmetry happening by chance is less than 1 in a billion. This unexpected alignment, observed across a scale of billions of light-years, implies that processes during the formation of the universe were not as random as we thought. This large-scale pattern challenges the long-held assumption that the universe is the same in all directions, a principle that underpins virtually all of our cosmological calculations. One of the explanations for this strange alignment is that our universe could have inherited the rotation of the object it was born from, like a massive spinning black hole in a parent universe. Schwarzschild cosmology. So this idea of a universe inside a black hole isn't entirely new. It actually falls under a concept known as Schwarzschild cosmology. The name comes from Carl Schwarzschild, who, back in 1916, found the first exact solution to Einstein's field equations describing the space-time around a spherical mass, what we now call a black hole. The model suggests that, well, the observable universe is the interior of a black hole existing within a larger parent universe. From our perspective, the Big Bang was the formation of this black hole, and from the outside, our entire cosmos would just look like a regular black hole. The size of this black hole's event horizon is defined by the Schwarzschild radius, and for a universe with the mass of ours, this radius is, interestingly, remarkably close to the radius of our observable universe. Mathematically, the singularity at the beginning of our universe is similar to the singularity at the center of a Schwarzschild black hole. The edge of our observable universe, which is a sphere with a diameter of 93 billion light-years, acts much like a black hole's event horizon, a boundary from which light cannot escape to an outside observer. Black holes as universe creators. Let's take this idea to its logical conclusion. If our universe was born inside a black hole, what does that imply about the estimated 100 million stellar mass black holes in our own galaxy? It suggests that each and every one could be a gateway, a seed for a new baby universe. This paints, honestly, a picture of a vast cosmic ecosystem, a multiverse where universes are constantly being born. This concept, known as cosmic natural selection and explored by physicist Lee Smolin, could even offer an explanation for the fine-tuning problem, the mystery of why the fundamental constants of physics are so perfectly set for life. If universes are constantly being created, then perhaps only those whose physical laws allow for the creation of stable black holes can themselves reproduce, leading to a multiverse dominated by life-friendly universes. This theory proposes that our universe is so adept at creating black holes precisely because it was born from one, continuing an unending cosmic lineage. Torsion and space-time twisting. For a universe to bounce instead of collapsing into a singularity, you need a powerful repulsive force at extreme densities. One candidate for this force comes from an extension of general relativity known as Einstein-Cartan theory. The mathematics behind this were developed in the 1920s by the brilliant French mathematician Élie Cartan. This theory incorporates a property of space-time called torsion, which accounts for the intrinsic spin of fundamental particles. This spin is a fundamental quantum property like mass or charge that gives particles an inherent angular momentum. In standard general relativity, space-time can bend, but it cannot twist, making the inclusion of torsion a significant modification needed for this theory to work. According to physicists like Nikodem Poplawski, at the densities found inside a black hole, the interaction between torsion and the spin of particles would create a powerful repulsive force. This torsion-induced bounce would be the mechanism that creates a new universe inside every black hole, making them not just cosmic destroyers but creators. Cosmic anisotropy. The evidence for a preferred direction in galaxy spins points to a concept called cosmic anisotropy. The idea that the universe is not the same in all directions. This directly challenges the cosmological principle, a foundational assumption in modern cosmology. This isn't just about galaxy spins. Anomalies in the cosmic microwave background radiation, first noted in data from the WMAP satellite and later confirmed by the Planck satellite, also suggest a large-scale alignment. Physicist João Maguejo famously dubbed this the axis of evil because it aligned with our solar system's plane, a result so strange it had to be a mistake, except it kept showing up with a statistical probability of being random at less than 0.1%. These anomalies, once dismissed as statistical flukes or errors in measurement, are now forcing a reevaluation of fundamental assumptions, which is exactly how science progresses. If our universe was born inside a spinning black hole, it would have inherited that axis of rotation, creating a preferred direction that could influence the formation and spin of galaxies. From the impossible galaxies seen by JWST to the mysterious alignment of galactic spins, we are faced with observations that don't quite fit our standard story of the cosmos. The idea that our universe is inside a black hole, born from a cosmic bounce, offers a potential framework to explain these anomalies without inventing new physics. It suggests we might be part of an endless cycle of creation. What do you think? Are we living inside a black hole? Let me know your thoughts in the comments below. Don't forget to like, subscribe, and hit the bell icon. Thank you for watching Future Facts. A massive visitor from deep space is flying through our solar system. The object, now officially named 3I Atlas, has astronomers worldwide both fascinated and honestly a bit terrified. Officially confirmed as the third known interstellar object, it carries an eerie potential. Is this colossal traveler a natural body, or might it be, an alien ship? Recent NASA data has sent ripples of fear and fascination through the scientific community, questioning everything we know about visitors from the stars. The breaking discovery. The discovery of 3Y Atlas marked a historic moment in astronomy, revealing a visitor unlike any seen before. Detected moving at an extraordinary velocity exceeding typical interstellar speeds, it challenged existing models of natural celestial object behavior patterns. NASA's advanced telescopes captured data suggesting anomalous properties, including unnatural acceleration patterns and an unusual trajectory that frankly defies conventional gravitational explanations. Researchers like Dr. Amir Siraj from Harvard University have highlighted these deviations as potential indicators of advanced propulsion systems, setting off widespread debate about the object's true nature among the global scientific community. The stunning size of 3Y Atlas far exceeds earlier interstellar discoveries, measuring approximately 10 to 15 kilometers in diameter, and igniting serious discussions about whether we are observing a spacecraft rather than a natural cosmic wanderer. From initial detection through detailed spectroscopic analysis, the international scientific community continues grappling with extraordinary possibilities ranging from exotic comet composition to genuine extraterrestrial technology. The implications of either conclusion would fundamentally alter humanity's understanding of our place in the cosmos and the nature of interstellar space. The discovery story. The remarkable story of 3I Atlas begins with its initial detection by the Asteroid Terrestrial Impact Last Alert System in early 2025, when automated survey algorithms flagged an object moving with unprecedented velocity characteristics. Astronomers quickly realized its trajectory was hyperbolic rather than elliptical, definitively confirming its interstellar origin from beyond our solar system boundaries. Its enormous size, estimated to be several kilometers across, dramatically dwarfed the infamous Oumuamua and 2I Borisov, making it by far the largest confirmed interstellar visitor discovered to date. Dr. Robert Warwick, who previously discovered Oumuamua at the University of Hawaii, coordinated initial observational campaigns revealing mysterious activity patterns indicative of possible artificial influence or control mechanisms. The object's calculated path through our solar system appeared to be deliberately planned, with intriguing timing and orbital alignments that prompted intensive scrutiny from major observatories worldwide. Global astronomical networks mobilized for an unprecedented international data gathering campaign, dedicating thousands of observation hours to studying every measurable aspect of the object's behavior, composition, and structural characteristics before it passes beyond detection range. A stranger in our midst. As 3I Atlas traverses our solar system, its extraordinary properties consistently challenge natural explanations proposed by conventional astrophysics models. The object exhibits complex outgassing patterns inconsistent with typical cometary activity, suggesting an internal energy source actively controlling its emission characteristics rather than passive solar heating. Advanced spectroscopic data reveals a surface composition featuring unusual metallic elements and compounds not typically found in natural asteroids or comets, sparking intense debate about whether it represents an artificial construct. Astrophysicist Dr. Marco Micheli from the European Space Agency has pointed out the object's highly reflective surface properties and precisely controlled thermal emissions as potential evidence of technological design and manufacturing. Most puzzling is the object's demonstrated ability to withstand intense cosmic radiation and extreme temperature variations without apparent structural disintegration or expected material degradation. These collectively puzzling characteristics make 3I Atlas a prime candidate in humanity's ongoing search for evidence of extraterrestrial spacecraft, fundamentally transforming how scientists approach the study of interstellar objects and their potential origins. The mounting anomalies continue defying conventional astronomical explanations while supporting increasingly exotic hypotheses. The predecessors. 3I Atlas follows in the cosmic wake of two notable predecessors that have, really expanded our understanding of interstellar visitors. Oumuamua, the first confirmed interstellar object sighted in October 2017, and Comet Borisov, observed in August 2019. Each of these brought unique mysteries that, honestly, challenged established astrophysical models. Oumuamua's extremely elongated, cigar-like form and its completely unexplained acceleration away from the sun-puzzled experts around the world, while Borisov displayed more conventional cometary traits including visible outgassing and typical orbital mechanics. NASA researchers including Dr. Karen Meech from the University of Hawaii's Institute for Astronomy have emphasized just how important it is to compare these objects systematically to really understand the true diversity of interstellar visitors entering our solar system. Their cumulative comparative studies suggest a broad spectrum of both natural and potentially artificial objects traversing our galactic neighborhood, hinting at a far more complex and dynamic composition of the interstellar environment than scientists previously conceived. The sequential arrival of 3I Atlas has really intensified international calls for establishing dedicated interstellar monitoring programs, capable of detecting and tracking future visitors with enough advance warning for detailed study. The cosmic journey. Traveling at incredible velocity with a definitively hyperbolic escape trajectory, 3I Atlas's epic journey from the depths of interstellar space really captures the imagination of scientists and space enthusiasts worldwide. The massive object appears to have originated millions, possibly even billions of years ago in a distant stellar system, and then embarked on this extraordinary voyage spanning both familiar and unfamiliar regions of our galaxy. NASA's Jet Propulsion Laboratory continues to support sophisticated computer simulations designed to understand how such enormous objects could, successfully traverse vast interstellar distances while maintaining structural integrity against all kinds of cosmic hazards. Dr. Alessandro Morbidelli's groundbreaking work in astrophysical dynamics specifically highlights the numerous challenges faced by such ancient cosmic voyagers during their extended journeys through space. The object's observed interactions with solar radiation, gravitational fields, and interplanetary magnetic environments provide invaluable scientific data about interstellar medium properties, directly benefiting ongoing research into cosmic evolution and galactic structure. Its successful arrival suggests either extraordinary durability of natural materials or perhaps possible artificial construction designed to withstand the harsh realities of long-duration interstellar travel. A scientific goldmine. The unprecedented arrival of 3I Atlas presents an extraordinary scientific goldmine, offering unique insights into the chemistry, physics, and material properties of objects originating beyond our solar system. NASA's James Webb Space Telescope has played an absolutely pivotal role in detecting previously unknown spectral lines within the object's complex electromagnetic emissions signature. Dr. Stefano Bagnullo leads international collaborative investigations that have successfully revealed unexpected complex organic molecules and exotic metallic compounds never before observed in natural celestial bodies. The accumulated observational data promises to shed revolutionary light on conditions prevalent in the early universe and the fundamental processes governing planetary system evolution throughout cosmic history. Intensive collaboration among international observatories has dramatically intensified, strategically leveraging multi-wavelength observations across the electromagnetic spectrum to capture the most complete scientific picture possible of 3I Atlas's true nature and composition. Scientists worldwide anticipate that these ongoing investigations will yield groundbreaking revelations capable of fundamentally reshaping humanity's understanding of the cosmos, interstellar chemistry, and the potential for artificial objects traveling between stellar systems. The scientific community recognizes this as a once-in-a-generation opportunity for paradigm-shifting discoveries. Unanswered questions. Despite extensive international study utilizing the world's most advanced astronomical instruments, there are still, numerous fundamental questions about 3I/Atlas that continue lingering without satisfactory explanations. Its documented orbital anomalies, mysterious surface composition, and those completely unexplained outgassing patterns consistently defy comprehensive scientific explanation using established astrophysical models. The persistent inability to detect conventional volatile substances typically associated with cometary objects fundamentally challenges existing theoretical frameworks and classification systems. Significant discrepancies between observed brightness variations and thermal emission patterns suggest complex surface interactions or perhaps concealed internal energy sources operating according to unknown principles. Leading astrophysicists like Dr. Sarah Seeger propose increasingly exotic alternative hypotheses, including the controversial possibility of artificial origin and extraterrestrial construction. The object's complete behavioral profile remains frustratingly elusive to researchers, continuously fueling heated ongoing debates within the scientific community, while at the same time, demanding expanded observational campaigns to decode its persistent enigmas. Each new measurement seems to raise additional questions rather than providing definitive answers, suggesting that 3I/Atlas may represent phenomena extending far beyond current scientific understanding. The mounting mysteries challenge fundamental assumptions about what constitutes natural cosmic objects. The alien question. The profound alien question has resurfaced with renewed scientific vigor as 3I Atlas continues exhibiting multiple characteristics that many researchers believe point definitively toward artificial origin rather than natural formation. Professor Avi Loeb, the prominent Harvard University astrophysicist and former chair of the astronomy department, argues compellingly that the object's unprecedented properties remain fundamentally inconsistent with any known natural explanations proposed by conventional astrophysics. He suggests that 3I Atlas could represent a genuine extraterrestrial probe deliberately sent to monitor or actively interact with our developing solar system civilization. This provocative and controversial assertion has sparked intense discussion within both rigorous scientific circles and broader public spheres, challenging established academic orthodoxies. Critics appropriately caution for maintaining rigorous evidence-based standards over speculative interpretations, but the continuously mounting observational anomalies increasingly pressure researchers to seriously consider dramatically expanded paradigms that accommodate the possibility of cosmic intelligence. The escalating debate highlights humanity's gradually shifting worldview as we potentially stand on the threshold of first contact with evidence of non-human intelligence. The implications of either confirming or definitively refuting the artificial hypothesis would fundamentally transform human civilization. Observing the visitor. Intensive observations from major global telescopes have dramatically intensified as 3I Atlas approaches its closest point to the Sun, offering unprecedented opportunities for detailed high-resolution imaging and comprehensive spectroscopic analysis. World-class astronomical facilities including the Very Large Telescope in Chile, NASA's Hubble and James Webb Space Telescopes, and extensive international survey networks have coordinated completely unprecedented observation campaigns. Dedicated research teams monitor measurable changes in brightness, trajectory, and emission patterns on a continuous daily basis, seeking any anomalous behaviors or structural modifications. The comprehensive data collection efforts specifically aim to capture transient phenomena including possible energy flares, potential communication signals, or unexpected structural alterations that might reveal the object's true nature. The global scientific community universally anticipates that these intensive coordinated observations could potentially provide definitive answers regarding the object's fundamental nature and ultimate origins, possibly marking a genuinely historic moment in humanity's ongoing search for extraterrestrial life and intelligence. The observational window represents our species' only opportunity to study this extraordinary visitor before it disappears forever into the cosmic void. Dawn of a new era. As humanity stands precariously on the brink of potentially transformative cosmic discoveries, the enigmatic presence of 3Y Atlas fundamentally challenges long-held assumptions about our species' place within the vast universe. The object's increasingly complex behavioral patterns hint at the possible existence of a greater cosmic network and unknown intelligences actively operating throughout our galaxy. Leading scientists now seriously consider the revolutionary possibility that Earth and its inhabitants might have been systematically observed for millennia by advanced civilizations possessing technologies far exceeding human capabilities. This profound paradigm shift compels our species to completely re-evaluate our cosmic role, not as passive observers gazing outward at an empty universe, but as active participants within a dynamic, interconnected, and potentially populated cosmos. The ongoing revelations emerging from detailed study of 3I Atlas herald what may represent a completely new chapter in both cosmic understanding and human evolutionary development. Whether the object proves to be natural or artificial, its mere presence has already begun transforming how humanity perceives its cosmic significance and future destiny among the stars. The dawn of interstellar awareness has arguably already begun. The unprecedented insights from 3Y Atlas have ignited both excitement and genuine concern within the global scientific community. Whether this massive object represents natural phenomena or artificial technology, its passage through our solar system forces a profound re-evaluation of cosmic possibilities. As intensive investigations continue, humanity waits on the cusp of possible contact and discovery. The universe may be far stranger and more populated than we ever imagined. Which aspect of this mystery fascinates you most? Share your thoughts below. If this cosmic investigation intrigued you, hit like, share with fellow space enthusiasts, and subscribe to Future Facts for more incredible revelations.